So today we're going to talk about something, a design or an architectural pattern, and it's this debate on if you have a complicated transaction or a complicated set of data, multi-page data, um, what do you need to ensure, give you the highest odds that you didn't corrupt some of that or that people didn't inject bad data or accidentally or on purpose. So, right, this is full model validation. Prior to the check, we give a loan, we give insurance, we enable a factory floor to do construction. We have something else that we do a full model valid. We run a full model validation against it. And we got to figure out what to do if it fails, because like we're already way down into something. But the idea is that we have risk, right? So this is really the last chance data validation, even though we think we've collected something good. And a lot of systems think they do this, but they don't always test the endpoints, right? So really what you kind of want is to make sure either it's directly wired or implicitly wired that you have this best chance. I worked one place where we called this full model audit, so I want to give them credit for that. What are the assumptions when I'm giving this talk? The failures carry regulatory or financial risk, that this isn't a casual posting, social media, some other kind of thing where it's a picture site or something. And that any mistakes that you make either could injure people, they could have physical risk, regulatory risk, or financial risk, and that you are risk averse. You would prefer, for various reasons, to have a very low percentage of failures. Everybody has some failures. The question is, which ones are important? Another assumption is that rules are expensive and they may require sequencing or coordination. So I may need to validate data or synthesize data in a certain order to make sure it's correct. Like I might top down look at it. And if I'm evaluating the data in a different order is bad. So I'm going to assume we have some kind of organized business rules, and they are required to make sure that we don't carry this risk or incur the risk. That there may be transient dependency failures. So you might have business rules that actually call other services, and we may let the user proceed, the transaction proceed, because we never want to hold them up. And in that case, we may want to pass at the end to give us another shot at those dependency services before we commit something. That this is a multi-page data capture. If you have a single page, it's really not that big a deal because you're going to submit one thing. But if you're collecting data across multiple mobile screens, multiple web screens, or some other method, then that aggregation gives injection points for failure or attack. And that we have a single large or multiple smaller coupled transactions. If you have one small transaction that's single page, this really isn't worth talking about. So the work stream, if we look at the work stream, right, basically I'm going to use this as the example work stream. We gather some demographics on a phone. Users on phones gather demographics. What's their name? What's their address? Then we do an income. We'll pretend this is a loan application. And then we gather something about the property we're going to use as collateral. And we capture their education because we believe education tells us something. And then at the end, we actually submit the application. So this is the work stream we're going to use as the example here. And so we have basically a 4 or 5 page application to gather some data, and it falls in there. So typically what we do is something called what I would call lightweight incremental validation. Each stage is as optimized API calls for validation for a better customer experience. And we run the minimum number of rules required to provide that experience. So in this case, we've got 4 sets of rules that run demographics, income, property, and education. And so the graph there was supposed to show that each one of these stages, we gather data, and man, those colors are all off by 1. No, they're not. Some are off. Anyway, you get the idea, right? And so we run the rules over time. And then when we submit the data at the end, we kind of hope that all those validations were valid because we validated each of the leaf nodes. And when we submit the graph at the end, we submit the entire graph as part of the transaction. We could have done sub transactions inside of this, but that can leave you open to data inconsistency. So you have to decide whether it's a large multi-phase commit, a bunch of tiny commits. Tiny commits are great, but they have their own issues. Yes, microservices people, I'm going to tell you that for certain transaction types. And so what do we got? We have a bunch of business rules that get applied in each one of the phases, right? So for the demographics phase, we have some rules, in this case, demo one. Those are supposed to be demographic 1, 2, and 3. And then we go into the income. And the reason I did this here, what I wanted to show is the income phase might actually have a one or more demographic, right? We captured some data on a previous screen. And so maybe we need to run some rule or some lookup service against that person based on something they answered in the income screen. And then we go into the property part of this because we're going to do a loan on a property. And so we have some questions, and then the business rules may actually, I have property rule 1 and 2 and 3, A and B here, and 3A and B may depend on which one of those we run based on income or demographics, right? So we have optional rules based on previous data, and those rules may not fail correctly if that data hadn't been collected. So the next one is education, right? So, and education, okay, we end up with 2 more demographic rules, and now we have 6 demographic rules applied in 3 different places. And then we have education 1, and that should have been education 1A and 1B. In this case, it's 1A and then a supplemental 1. And so you can see we've got a set of business rules we run at different places. And then when we submit the application at the end, we've got 3 sets of 3 rules that need to run to validate that the submission's ready to go. But that may not be validating everything if we're going to assume that the other data was validated. And so we just have some submission rules here that you filled out the page the submission's on in this case, right? So what happens if we get an accidental or a deliberate bypass here? We have how could this happen? Oh, no. In this case, we went demographics, income, we skipped property, we went to education, then we went to submit, right? And because of the way this has worked, none of the education and submit phase may actually do a full model validation. And so they're going to assume that you got here and that the property definition is valid because none of the other downstream rules needed to look at the property, right? So in this case, how could this happen? Back button, direct nav in a web app. People went to a URL directly and hacked on it. They run in multiple windows. That's another one. We have somebody attacking it with scripts. We have people doing URL manipulation. I will admit, sometimes I'll run the same app in 2 places so I can still see an old screen. There could be programming errors. This can happen a lot, right? Hey, we skipped a page or we bopped over it somehow. We didn't pick it up. You get a microservice. I don't know. Why did I say that? Because the microservices organization is the notion you have a bunch of very fine-grained services that get invoked to do things. It makes it easier to release. It also means that you may not have a macro service to validate, that the microservices each take care of their own, they each manage their own business, and so none of them know about the broader structure. That's why I said that. And we could have unexpected calls that get added into the code. I actually seen this where we have a service tier, 2 versions of the app, and one of the versions of the app called APIs that were intended for the other version. And because of the way permissions and stuff work, we didn't pick up on that maybe. And then we have the submit application. So in this case, we have accidental or deliberate bypass. And so what does that mean? That means we skipped a bunch of rules, right? So we have demographics, we did the income, we ran property, and we missed the property rule. And, maybe the education and submit application, the default set of rules required to just process that page. The microservices to be called don't do a cross-validation against the property in this case. And so the property might actually get dropped, right? Which is really weird. But I've seen stuff like this happen in more complicated apps than the one I'm drawing here. So the notion is that in that last phase, we have one last chance on submission to make sure this. Now, so in this case, what we would run is all the demographics rules that I put on the previous page, the income rule, property rules, and then we would slap on an extra run of the submit application rules. Now, these can be really expensive, right? So we optimized the previous screens for performance, and therefore we didn't run all the rules every time because that would be dumb. And in the happy path situation, we get down at the end, we wouldn't have needed them anyway, right? So what I'm proposing is that if you have and what makes this easy? If you're well organized. If you're poorly organized and you let people just kind of code randomly, this can be really hard to implement because you don't actually know where all the rules are and you don't know what they are, right? So I'm going to say, though, that in certain situations, you're going to need to want to run a full model validation, which is the sum of all the rules, and they might get applied in rule set order that we show here. I'll do a different set of talks on rule sets. So this is expensive, so we got to decide it's worth it. But if we have financial or regulatory risk, it is. So what are we going to do to make this happen? This is the last screen. We're going to plan and organize to support the full model validation. I mean, this can't be ad hoc, man. It's just never going to work, right? We must have a copy of the rules run on the server side because we need to protect the server. We could have a version on the client side to give them better turnaround, but guess what? We don't trust the client. So full model audit I'm like, in some cases, I know we want to do full model audit on the client itself, like in a native app, maybe, but we should assume the native app's been hacked on the back end, on the API tier, so we could never trust the client. We need to have a rule pattern because we're going to want to apply these different sets of rules, maybe in the full model audit without having to rewrite them. And if you just kind of randomly hand code them anywhere in anonymous functions, you're dead, right? So in many cases, this is mandatory for the web because people can do whatever they want for the web, and the client is completely untrusted, even from high school students. On the mobile side, we still can have this problem. People can hack a mobile app, maybe or maybe not, but they could write their own mobile app, actually, that synthesizes, that looks like yours, and that would let them do the calls. Because they could sniff the wire. You could do other things, right? Anyway, but it's really mandatory on the web for sure, and potentially other platforms. We're going to want to bundle the rules into identifiable sets like I showed on the previous pages so that then we know when to run them by purpose. You don't see this a lot. A lot of times people will put them in a controller, they'll put it somewhere, a validator. But in this case, what I really want is to bundle the rules close to kind of sets that represent where they would most commonly run. And we don't want a bunch of random rules to run because they could fail on a page where they aren't needed. So we tend to make these kind of smaller groups. And then for the full model validation, we kind of bundle all those together. And then we're going to inject a full model validation run prior to the transaction commit. So we might do that last page in the previous diagram where we actually do the submission. That submission we may take a little longer because we might fork off a full model validation, and that may involve database calls and others. And then we need to broadcast to everybody that this is our strategy so that all the developers understand they need to take this into account, and nobody should be allowed to break the pattern. So that's it, 12 minutes. Man, this one longer one for one of the ones lately. And the whole idea here is that there are situations where there is fiduciary risk or complicated business rules or financial risk or physical risk or something else that we may want to take on the overhead of being more disciplined in our rule structure and be able to apply the full rule set at the end in case we either missed them, because a lot of times you'll have optional rules, or in case somebody came into the app on a path we didn't expect it. And that's it. Have a great day.